Lesson 2. We accomplished quite a few things in our first lesson. In this lesson, I want to focus on 2 additional tasks. One, I want to show you how to edit a program that you've already constructed. And second, I want to show you the first of the control structures. All right, let's move ahead. Turn the calculator on. And this time, let's look at the programs we've got. By the way, I've got a different illustrative program that I'm going to run at the end of this session called Amortize. But let's look at that program that I called AIM. I'm going to scroll down to it, and this time I'm going to scroll over to Edit. All right, I've got those 2 areas blackened. I'll press Enter, and that calls up the program steps that we originally entered in the calculator. Now, I can make changes in this now. First of all, I can change a letter. I used the letter S to prompt before. I could change that to B for beginning number or something like that, simply by typing over it, alpha B. Now, I want to be careful here because if I'm going to change that to B, I better change this one to B also. All right? So there's one way of making a change. I could change the numbers too. I could change the 5 to a 1. I could change the value A to something different. So I've got B for beginning number, A for answer. But this B plus 1 is a pretty straightforward task. Let's make it a little bit more complicated. Now I want to insert 2 times in front of the B to make it 2B plus 1. To do that, I need to insert a number. Well, I've got a key that's INS here for insert, second, INSS. Now, before the calculator would replace what I have there, but now it will insert something in front of what's there. So I simply type the 2 times, and it goes in. Notice the times, as most of you understand, is an asterisk in programming. All right, so now I have a program that's changed. Instead of having B plus 5, I now have the program 2B plus 1. Now let's see the result of that. I can get out of the program by quitting and run this new program, game. Now I've got a beginning number to put in. Suppose I put in 2. Now remember what happens. This time that number gets doubled and then add 1. And appropriately we get 5, we could run it again for 10, double that and add 1, and so on. Now once again, I've called the program game because this is a program that you could use. Ask the user to guess what the program is doing. And you can make very sophisticated little calculations, and it's good practice for someone to try to figure out what's happening. And all they need to do is to keep checking numbers to see, and once they make a guess, they can test their guess by doing another calculation. Okay, so much for that, for how to edit. Very straightforward. Simply go into the program edit mode and you make your changes. Now the first of the control structures. I'll show you this by making a second program here. A new program. By the way, notice I could use the scroll left key and this circles around and goes on to new. Big deal. I press the enter key and I've got a name. I'm going to call this program GOTO because that's the control structure that I'm going to introduce. Some of you familiar with programming may question my using this as the first control structure because it's one not often used in advanced programming, but it's an important one and the other structures are generally based on it. Now, the GOTO instruction allows you to change the order in which the instructions, the steps, are calculated. Normally, the steps are calculated 1, 2, 3, 4, in the order in which you place them. But a control structure allows you to change that. Here's the way this GOTO instruction works. You put a label with a name, and then a series of steps, and then this GOTO, when the calculator comes down to this step, it goes back up to that label and goes through the steps again, so that this forms a loop. All right, let's do something with this form. I'm going to start by storing 0 in the value n. That'll initiate the program that I'm going to construct. Now remember, I've got to have a label here for the beginning of my loop. So I will go into Program, and remember, this is a control structure, so that's what all of these things are. This what happens to be quite a ways down here. Notice label and GOTO are next to each other. I'll scroll down to label, press the Enter key. Now I could give this a name like A or S, but I'm going to give it a name as a number. I could use numbers for it as well. All right. Now we've got that instruction. By the way, I don't know if I've said anything about these colons. The colons separate the steps. There is a key down here that you can type a colon. I could have written 0 store n colon label 1 and written the program in paragraph form. This makes it neater, however, and by the way, much easier to correct or to edit. All right, now let's do something quite simple here. I'm going to take this value n, add 1 to it, and store it back in n. That seems like a kind of an odd trick. Now remember, here's what that will do. N is a storage place. It's going to start out with that 0 in it. Now it takes that number out, adds 1 to it, and puts the value back in. So then the value of n becomes 1. All right, the second time through the loop, n will be 1 plus 1 will be 2, and so on. All right, now we want to display what that number is. Remember how to do that. Program, I/O, there it is, display, and we're going to just display the current value of n. And now I want to complete my loop so that I'll go back and just repeat those 2 steps. Now how do we do that? Program, it's a control structure. Scroll down to it, and there it is. And where do I want to go? Back to the label that I've named, GOTO 1. And there's my program. All right? It's a simple 5-step program, and let's see what it does. I'll leave the program mode back to my home screen. I'll press Program, and this time we want to execute it. So let's go down to GOTO here, that we've called it. By the way, there's you certainly don't need to name a program after the structure that you're using. I just did it here as a memory device. I'll press Enter. Now what's going to happen here? Some of you may be surprised. I'll press the key. Wow! What am I doing? I'm counting. In fact, the calculator is going to go on as long as we don't do anything to stop it, or the battery runs down, which is something that can happen after a while. Now, that's one of the problems with this GOTO loop, is there isn't anything in that loop that's going to stop it. There's no reason for stopping, so it'll go on essentially forever. But we have one tool to stop any program that's operating, and that is to go down here and press the on key. Serves as what's called a break in the program. I'll do that. Better press it hard enough so it'll take. And it stops the program, and if I press again, it'll show it stopped at 208. That break gave me this error signal. All right? By the way, one of the things that allows you to do is to see how fast the calculator is doing those calculations. Remember, it's looping through 4 steps, each time it writes one of those numbers down. And I timed it myself a few minutes ago, and I found that it was doing 18 of those lines, 18 of those numbers per second. That's a pretty fast operation for a little toy like this. I use the word toy loosely because this is a powerful little calculator. All right, I'm going to do one more thing with this program. I'm going to go back into it and edit it. That'll remind us how to edit. Be sure to call up the right program and edit. And this time I'm going to add a step. After I display n, I want the calculator to stop for until I have it to go on. Now I want to insert a line of code here. So I'm going to use this insert key. That second insert, and to get a new line there I press enter. Aha, there we are. I scroll up to it, and now I can put in, I want to put in the instruction pause. It's also among the keys. Now let's see what that does to the program. I'll exit. This time if I run the program, now it's paused. By the way, the calculator is still running. It's going through a little loop that's internal to the calculator. So if I simply set the calculator aside now, it would continue to work until it ran your battery down, just as it would have before if I kept printing those numbers. So be careful. Don't ever leave your calculator in pause. If you turn it off, it'll stop too, of course, but don't leave it in this pause form. Let's see what happens now if I press enter again. And each time I get out of that pause by pressing the enter key, so I can get those numbers one at a time. Pause is a very useful key in many program settings. It stops you temporarily. All right, now once again, to get out of this program, I still have to press on for my break, and it gives me the error, and I'm done. Now once again, last time I gave you an example of a little graph-like program that printed those polygons in nice arrays. This time let me show you a program that you might use in your own shopping. I called it amortize. I'll run that program. Suppose you're looking for a used motorcycle. Now, motorcycles are very expensive nowadays. And let's say that you're looking around for a motorcycle that will cost $10,000. Well, you don't have $10,000 at hand immediately. So you're going to pay this. You have to borrow the money in order to pay for this. And you want to see how much you're going to have to pay off in different payment plans. That's the whole idea of amortizing a loan. So we want to borrow $10,000. And now let's say we're going to pay this monthly, and that the monthly charge is 1%. By the way, that's not necessarily a low charge, a little over 12% a year. But let's see what would happen now if we would charge 1%. And let's say we wanted to do this for 5 years. Now remember, we talked about 1% a month, so 5 years would be 5 times 12, or 60 months. Whoops. I can correct this, 60. And let's see what we would have to pay each month. $222.44. Can we beat that with our income? Well, that's something to be determined. But there's something else you could do here. Let's see how much you would actually pay for that $10,000 motorcycle if you did this. We'd have to make 60 of those payments, so I can multiply that value by 60 and see that, my goodness, you'd have to pay over $3,300 in interest over that 5-year period. All right, let's try this again and run it again. Let's do this $10,000 again at 1%, but this time, well, maybe we can't make those payments, so what do we do for 10 years? Well, that would be 120 months. What would be the payments then? $143 and a half. So, and if we multiply that by 120, now you're paying over $7,000 in interest. So here's a useful program.